Hello, grade 11s. We're going to continue talking about solving quadratic equations, and today we're going to learn how to solve them by graphing. Now, we can set up a table of values and solve them that way by manually graphing on graph paper. Today we're also going to use the Desmos app to solve it with technology. Okay, let's get started. First of all, standard form of a quadratic equation, that should be becoming like old hat for you, meaning you should know what that is off the top of your head without thinking too hard. So, quadratic means it's got a variable squared in it. We usually say it's ax squared, where the a is any number not 0. Right? As soon as a is 0, 0 times x squared, the equation no longer has a squared in it then. Plus bx plus c equals 0. Notice that here we sometimes write y. If we're talking about standard form of a quadratic equation, standard form has it equaling to 0. Okay, so y we know is 0 in standard form. All right, now, to solve a quadratic equation means what? To solve means to find the value or values, that should have an S on it, of x that make the equation equal to 0. What are some words that also mean solution? So when we say solve, we mean find the solution. What are other words for solution? Well, we could say roots. We could say x-intercepts. Keeping in mind that the places where y equals 0 will always happen along the x-axis. The whole x-axis is the place where y equals 0. So solution, we could say roots, we could say x-intercepts. Sometimes they're called zeros because that's where y equals 0. So how many solutions can a quadratic equation have? Good question. So let's pull the screen down here. You'll need to notice this same page on your notes. Here's 3 examples of parabolas, of graphs of a quadratic equation. Now, we can see the places where these 3 examples cross the x-axis. If we look at the red graph, we can see that it has 2 solutions. It crosses the x-axis in 2 places. If we look at the yellow graph, we see that that parabola has 1 solution, or 1 place where y equals 0, because it only crosses, or touches, I should say, the x-axis once. And on the blue graph, we see that that parabola has 0 solutions. It doesn't cross at all. So, to answer the bottom question then, how many possible solutions are there for a quadratic equation? Well, there's a possible 2 solutions, or a possible 1 solution, or a possible 0 solutions. I'll use the abbreviation there to make it fit. Okay, so 2 solutions, that's again when our parabola, like the red one, or like this, if it opens downward, would have 2 solutions crossing twice. 1 solution when the vertex is right on the x-axis, like that, or if I draw the other option, it would be opening up, where it would have 1 solution, touches once. Or like the blue graph, it doesn't touch at all, and that could happen if it's completely below the x-axis as well. Okay, turn the page. So we're going to solve today by graphing. And we're going to, first of all, just do the old-fashioned table of values, and then, secondly, we're going to put it into Desmos to check our answer, and so you can learn how to do that. Those 2 boxes at the top, then, they give you step-by-step instructions of how to solve a quadratic equation in standard form on a graph. So number 1, you can see the first box here. I'll grab my highlighter. Step 1, graph the equation. Step 2, look and find the solution. Not too difficult. And we'll get to the second box when it applies. So let's solve this first quadratic equation. So what was the first step in this aqua colored box? To solve a quadratic equation in standard form. So we need to first determine if this is in a standard form. Grab my pen here. Standard form, we know, has to be equal to 0. So in this case, it's pretty easy to turn it into standard form. We need to add 6 to both sides. Okay, and once we add 6 to both sides, that will create 0. That was the point of doing it. And now standard form is x squared plus 5x plus 6 equals 0. Okay, so I'm going to draw a quick table of values right here, just like we did yesterday in class, and then plot the points on the graph there. You go ahead and do the same thing on your paper. One more little thing. When I make a table of values, I have an x column. I've got the equation to plug my x into, and then I have a y column. Now, when I look at standard form, the y is not there, right? We've replaced y with 0. Okay, so this, when we replace y with 0, that helps us to look for the zeros or the solutions, the intercepts. But when I want to draw the whole parabola, I need y to be, well, whatever it is when we put in an x in order to plot all the points. Okay, so that's why there's a y in this case, and there's a 0 in this case. Okay, so I've got the chart drawn out there, and you can see my ordered pairs, and if you want to write them, x comma y for each pair, so that would be 0 comma 6, 1 comma 12, etc. Okay, 1 comma 2. Now when I look at the x-axis here on the graph that's provided, it's okay because it goes from -4 to +4. And our x values are in that range, but I see my y's here are not going to fit on the scale that was given. So let's just, on the y-axis, let's count each line as 1. So then this would be 4, this would be 8, this would be 12. Okay, that will make better sense. Okay, so 0 comma 6, 0x on the y-axis 6, 1 comma 12, 1 on the x-axis, and then +12. -1 on the x-axis and +2. I'm seeing a slow curve here, so this is good. -2 comma 0 and 3 comma 0. Okay, so I can kind of imagine already how this is going to look. It's going to come down, draw a nice and even slow curve, and then here it starts curling back up. Okay? And my vertex, or the very bottom, must be in the very center of the 3 and the -2. So it's at like -2.5. I'm not quite sure how low it goes, but we can see that. Now, it says solve, right? You see that word there? Solve. What we were looking for is the place where it crosses the x-axis. So we have 2 solutions in this case. If I grab my pen back, I can write here a solution set of x equals -2 comma -3. Okay, we usually list them greatest to least. They're in these curved, nice brackets that represent solution sets. Now, I want to get Desmos, so I'm going to give you a chance to pause it, please, and I'd like you to download the Desmos app on your phone or on Google, on the internet, on Safari. You can look up Desmos and get that free graphing software open. Okay, here's the Desmos app. You can see on the left-hand column there is numbered places to enter equations. You can also see you can open up a little keypad here, and we're going to key in now the quadratic equation that we were working with. So I've got x squared plus, okay, you get the idea? Go ahead and key the rest in. Okay, and you can see when I key it in that I don't need to have the equal 0 here, okay, just the equation. As soon as I push equal 0 here, it's going to give us two straight lines, and actually it does give us the whole solution, but let's delete those and so we can see the parabola. Okay, now we remembered that to find the solution, or to solve, means to find where it crosses the x-axis. Now, if you mouse over that exact spot, you will see an ordered pair pop up. The x value here has a -3 and the y value has 0. This is one of the solutions, -3, and the second solution here, -2. So, if I toggle back to the smartboard, you can see that we get the same answers as our long by hand graphing here. Let's answer these questions together. How many solutions are there? Well, if you look at the places where it crosses the x-axis, there are 2. What are the solutions? Well, we wrote that up there, but I can write it again. Right. Can you factor this? Okay, let's try. Going back to the top and see if you can factor that quadratic. Notice it's simple trinomial. I'm just doing this up here with that x. I need two numbers that multiply to 6 and add to 5. Those numbers are 2 and 3. If I would factor this, I would get x plus 2 and x plus 3 equals 0. Interesting how that relates. Let's zoom back down. How does that relate to the solutions we found? Well, it's interesting. They're the same numbers, opposite signs, isn't it? Yeah. Graph the quadratic if we did that. And yeah, it's easy to check our solution. Oh, how can we check it without technology? Well, the -2 and the -3, if I would put that in for x, I would need to equal 0. If it doesn't equal 0, then we screwed up somewhere. Okay, moving on to the next page. Solve this by graphing. Okay, so I'm going to leave you to plug that into Desmos and answer those questions. Here's the graph I get when I plug that in, and you can see that my solution is -3. So I could write in here, there's one solution. What are the solution? X equals squiggly brackets, oops, -3. I don't need 2 dots there. Verify your solution. Okay, well, if I put a -3 in for x, do I get 0? Hopefully I get 9 minus 18 plus 9 equals 0. Verified. Okay, next one. Go ahead and get it done. Hopefully you got 2 solutions, and when I put my mouse right on top of those x-intercepts in Desmos, it said that x was equal to -2.245 as well as 0.445. Now, number 4. This is a little bit different strategy here. You'll notice that we've got 2 sides to this equation. Now, we could go ahead and simplify this equation, bring everything over to one side so that it equals 0 and it's in standard form. The only problem with doing that is that there's room for error, like you might screw up somewhere. So what we're going to do is put both of these sides into their own equation in Desmos. Okay, just take the exact same thing, you can copy it and then paste it into Desmos, or retype it if you want. Go ahead and do that. You can see the 2 sides of the equation here on the left. The first side, the left part is red. The right part of the equation is graphed in blue. Now, look where they intersect. That's going to be your answer. So when we graph 2 sides of the equation, we look for their intersection points. So our one answer is 0.319. Our other answer is 1.881. Let's write that in. So here are solutions written in. Notice that it was the x coordinate of their intersection points of both sides of the equation. Okay, good luck with your assignment here, grade 11s, and we'll see you in the classroom.